51. Why are alarm and trip values tested? Alarm and trip functions protect rotating equipment from excessive vibration. Testing ensures that the machine protection system responds correctly before the equipment is placed in service. 52. What should be done after completing the dynamic test? After testing, reconnect the original field probe, restore all wiring, and verify the normal gap voltage. This confirms that the system has been returned to its original operating condition. 53. Why is the oscillator, proximeter, opened during testing? The oscillator housing may be opened to disconnect the field probe and connect the TK3 calibration cable. This allows testing without affecting the permanent installation. 54. What DCS indication should appear when the probe is disconnected? The DCS or machine monitoring system should display a bad PV, sensor fault, or channel fault alarm. This confirms that the monitoring system can detect probe failures. 55. Why is a tested sticker placed on the oscillator? A tested sticker indicates that the loop test has been successfully completed and accepted. It helps prevent unnecessary retesting and provides visual confirmation during commissioning. 56. What should be done if the installation differs from the drawing? If any discrepancy is found between the field installation and engineering drawings, raise a punch item or site query. The issue should be resolved and approved before commissioning. 57. When is a dummy probe used? A dummy probe is used when the installed proximity probe cannot be removed due to machine constraints or operational restrictions. It allows loop testing without disturbing the actual installation. 58. What is the advantage of using a dummy probe? A dummy probe enables complete functional testing of the monitoring system while protecting the original probe from damage. It also reduces commissioning time and avoids unnecessary machine disassembly. 59. Why is a dummy extension cable sometimes required? A dummy extension cable is used when the original extension cable is inaccessible or permanently installed. It allows the complete probe driver monitor loop to be tested under simulated conditions. 60. Why should the original probe be reconnected after testing? The original probe must be reconnected to restore the machine protection system to its normal operating condition. After reconnection, verify the gap voltage and ensure all alarms have cleared. 61. What is a Keyphasor? A Keyphasor is a non-contact proximity sensor that generates one pulse for every revolution of the shaft. It provides a reference signal for measuring shaft speed and vibration phase angle. 62. Why is a Keyphasor used in rotating machinery? A Keyphasor provides an accurate shaft speed reference and phase reference for vibration analysis. It is essential for machine protection and condition monitoring systems. 63. Where are Keyphasors commonly installed? Keyphasors are installed on steam turbines, gas turbines, compressors, generators, and large motors. They monitor the speed and rotational position of critical rotating equipment. 64. What is the working principle of a Keyphasor? The Keyphasor operates on the eddy current principle. As a notch, keyway, or projection on the shaft passes the probe, it generates a pulse that indicates one complete shaft revolution. 65. How many pulses does a Keyphasor normally generate? A standard Keyphasor generates one pulse per revolution, 1x. Some applications may use multiple pulses per revolution depending on the machine design. 66. What parameters can be measured using a Keyphasor? A Keyphasor is used to measure shaft speed, RPM, rotational direction, phase angle, Reference position for vibration analysis. 67. What is the normal supply voltage for a Keyphasor system? The proximeter, oscillator, supplying the Keyphasor is typically powered by -24 volts DC. This voltage should be verified before starting the loop test. 68. What is the normal gap voltage of a Keyphasor probe? The normal gap voltage is approximately -9 volts DC to -10 volts DC, indicating that the probe is correctly positioned within its linear operating range. 69. Why is gap voltage checked before testing? Checking the gap voltage ensures the probe is installed correctly and will generate reliable speed pulses. An incorrect gap may result in missed or unstable pulses. 70. How is a Keyphasor statically tested? Static testing is performed using the TK3 calibration instrument and micrometer. The probe output is checked by varying the gap between the probe and the target. 71. How is a Keyphasor dynamically tested? Dynamic testing is performed using the TK3 wobble plate, which simulates shaft rotation. The monitoring system verifies the generated pulses and displayed RPM. 72. Which RPM values are typically verified during loop testing? The procedure generally verifies low speed, approximately 200 RPM, medium speed, approximately 3350 RPM, high speed, approximately 6700 RPM. This confirms accurate speed measurement across the operating range. 73. Why are multiple RPM values tested? Testing at different speeds confirms the monitoring system accurately measures shaft speed under various operating conditions and ensures reliable machine protection. 74. What should be verified on the DCS during Keyphasor testing? Verify correct tag number, correct RPM indication, pad PV alarm, speed alarms if configured, communication with the machine monitoring system. 75. What happens if the Keyphasor probe is disconnected? The machine monitoring system or DCS should generate a bad PV, sensor failure or channel fault alarm. This confirms proper fault detection by the system. 76. What is the purpose of a dummy Keyphasor probe? A dummy probe allows complete loop testing when the installed probe cannot be removed. It prevents disturbance to the machine while verifying the monitoring circuit. 77. Why should the original Keyphasor probe be reconnected after testing? The original probe must be reinstalled to restore the machine protection system. After reconnection, verify the gap voltage and ensure all alarms are cleared. 78. What are common faults found during Keyphasor loop testing? Common faults include incorrect gap voltage, loose wiring, damaged probe, faulty extension cable, failed proximeter, oscillator, incorrect probe mounting. 79. Why is the Keyphasor important for vibration analysis? The Keyphasor provides a reference point for each shaft revolution, allowing vibration monitoring systems to determine the exact location and cause of vibration, such as imbalance, misalignment, or shaft bow. 80. What is the main objective of Keyphasor loop testing? The objective is to verify the complete signal path from the Keyphasor probe to the monitoring system and DCS, ensuring accurate RPM measurement, reliable fault detection, and proper machine protection before commissioning. 81. What checks should be completed before starting an MMS loop test? Before starting the loop test, verify the instrument installation, cable continuity, power supply voltage, termination, grounding, shielding, and calibration certificates. Also ensure all engineering documents and loop test sheets are approved. 82. Why is cable continuity checked before loop testing? Cable continuity confirms there are no open circuits or broken conductors between the field device and the monitoring system. This prevents unnecessary troubleshooting during commissioning. 83. Why should cable shielding be checked? Proper shielding protects low-level vibration signals from electromagnetic interference, EMI. Incorrect shielding can cause unstable readings and false vibration alarms. 84. What should be verified after energizing the MMS rack? After energizing the rack, verify power supply status, module health LEDs, channel status, communication status, no active hardware faults. 85. What is the purpose of the Bentley Nevada 3500 rack? The Bentley Nevada 3500 rack receives signals from machine monitoring sensors, processes vibration and position measurements, generates alarms and trips, and communicates with the DCS for machine protection. 86. Which modules are commonly installed in a Bentley Nevada 3500 system? Common modules include Rack Interface Module, RIM, Power Supply Module, Vibration Monitor Module, Position Monitor Module, Relay Module, Communication Gateway Module. 87. Why is rack communication verified during commissioning? Communication verification ensures that all machine parameters, alarms, and trip signals are correctly transmitted to the DCS or PLC for operator monitoring and protection. 88. What should be checked on the DCS during loop testing? Verify correct tag number, engineering unit, measurement value, alarm status, trip status, pad PV indication, signal updates. 89. Why are alarm set points tested? Alarm testing confirms that the monitoring system warns operators before equipment reaches unsafe operating conditions, allowing corrective action before damage occurs. 90. Why are trip set points tested? Trip testing verifies that the machine protection system automatically shuts down the equipment when vibration or shaft position exceeds safe operating limits, preventing catastrophic failure. 91. What is the difference between an alarm and a trip? An alarm warns the operator that a parameter is approaching its limit, while a trip automatically shuts down the machine when the parameter exceeds the shutdown limit to protect equipment. 92. What should be done if the vibration reading is unstable? Check probe gap, cable shielding, grounding, loose connections, probe mounting, electrical noise, power supply voltage. Unstable readings are often caused by poor installation or EMI. 93. What are common faults in a proximity probe system? Common faults include incorrect gap voltage, broken probe cable, damaged extension cable, failed proximeter oscillator, loose terminals, wrong probe installation, poor grounding. 94. What causes a bad PV alarm? A bad PV alarm may occur due to sensor failure, open circuit, short circuit, power supply failure, communication loss, disconnected probe. 95. How do you troubleshoot a bad PV alarm? First, verify the power supply, then check cable continuity, probe gap voltage, extension cable, oscillator, field wiring, and DCS communication. Replace faulty components if required. 96. Why is machine protection important? Machine protection prevents costly equipment damage by continuously monitoring machine condition and initiating alarms or shutdowns before a serious failure occurs. 97. What documents are completed after loop testing? The following documents are normally completed: loop test sheet, calibration report, commissioning checklist, punch list if required, test records, client acceptance documents. 98. What precautions should be taken during MMS loop testing? Follow lockout tagout (LOTO) procedures. Obtain work permits. Use calibrated test instruments. Protect sensors from physical damage. Coordinate with operations before testing. Follow vendor procedures and safety requirements. 99. What is the final objective of machine monitoring system commissioning? The objective is to verify that every sensor, cable, monitor, alarm, trip, relay, and DCS indication functions correctly, ensuring reliable machine protection before startup. 100. Why is machine monitoring system testing critical before plant startup? Machine monitoring systems protect high-value rotating equipment such as turbines, compressors, and generators. Thorough testing ensures early fault detection, reliable operation, and prevents costly downtime and equipment damage during plant operation. Thanks for watching. Please subscribe, like, share, comment. IIQA